your 3D cursor, and your 3D cursor is that thing, that weird little thing, little crosshair at the bottom there. That's your 3D cursor. And yeah, I don't know, Blender has a 3D cursor, maybe other applications don't. It's going to put it there. And if you don't want it there, you can move that 3D cursor somewhere else by hitting Shift and right-clicking. And you can see it's now moved it and actually attached it to the plane, which is where we want it. If you don't have a mouse, do get a mouse. But in the interim, you can also use the cursor tool, and that'll do the same thing. All right, so we're adding long sprinkles. So obviously the object that we want to add is Shift-A, Mesh. It's the cylinder. Okay. Too big by default, so let's click this little thing, bring this up, change the radius all the way to its lowest and the depth. Obviously the object that we want to add is Shift-A, Mesh, it's the cylinder. Okay, too big by default, so let's click this little thing, bring this up, change the radius all the way to its lowest and the depth all the way to its lowest as well. And the vertices, that's the like the resolution, right? Oh, we'll fix that in a sec. The resolution would be way too high at 32 to be scattered on an object. So let's set this to 12, and that'll be just enough that it won't look jagged and it'll look smooth. Okay, great. Now I'm gonna move this up just so it's above the plane, Z. Okay. Now this problem that you have, if you go in too far, it disappears. The reason for that is that Blender has a clipping start value. And because we're working at such a small scale, we've got sprinkle-sized things now, it's too small and it's clipping it out. So if you hit N and go to your View tab, the clip start value there, it's 1 centimeter by default, drag it all the way to the left, and it's now 1 millimeter, and it will have fixed that. I don't know why it's not the default. Like, maybe somebody can tell me why is that not the default value? Maybe there's a reason, but to me that would make sense because then you never have this problem. I don't know any disadvantages. So anyway, we've got the base of a sprinkle. Need to make it long, so tab into edit mode, S, scale it Z along the Z axis to elongate it, and now we've got the rough length of a sprinkle. But how long is a sprinkle? There's no actual answer to that. If you look at reference, they are all over the place. The government evidently never stepped in and said, like, we're gonna regulate it. This is the length of a sprinkle. This is the size of a sprinkle. I mean, it's the Wild West out there. They're doing crazy things. So what that means as artists is we get to pick whatever is most visually pleasing. And I like the ones which are more readable. And to show you what I mean, if we pull up 2, right? This one on the left is like large sprinkles, right? Very like bold. And then one on the right here is like long, thin, wispy ones that look like they get stuck in your teeth. And if we zoom out on this and then zoom out on this, you can see that the ones on the right tend to kind of like, the colors and everything just kind of blur together and it just looks like a donut. Whereas the one on the left, the sprinkles are still readable. So that's what we mean by readable, and that's the one I like the most. So we're gonna go with some larger looking long sprinkles, but you can see that the sizes, there's no standard size because I think it's actually like it's from a piping bag, at least if you make them at home, but you can just pipe out icing and then when it dries, you just smash it up and it becomes sprinkles. But yeah, they just come out at any odd size. So we got long ones, we got medium ones, we got short ones, and we've even got some curvy looking ones, right? These little like just slightly bent-ish looking ones. So We're going to model small, medium, large, and a bent-ish looking one, and then we're going to scatter that across the object. So back in Blender, this is going to be, yeah, this will be the short one, okay? But the end, speaking of which, this end bit here, it's a very sharp edge, and even if we hit shade smooth, it's not going to solve it. We want that like a rounded form to it, not this horrible. Blobby looking shape, because the reference, again, you can see, oh, it's a different reference now, is a rounded shape. All right, so to create that rounded form, we're going to create a bevel, and so I want you to go into face select mode, okay, which you can do by that. So this is the faces, right? This is the edges. If you go to edge select mode, and then this is the face there. So select the bottom and the top face like that. And then we're going to add a bevel, which will immediately become clear when you do it. Control B. And now that we're in this state, as we pull out, we can change the amount of the bevel. And this is, you can see it's like, yeah, it's just adding a 45-degree angle on that corner there. Control B. And now that we're in this state, as we pull out, we can change the the amount of the bevel. And this is, you can see it's like, yeah, it's just adding a 45-degree angle on that corner there. But if you scroll up, it's going to add another level to it. And if you scroll up again, it's going to add another level to that. So we can very quickly create a rounded edge to the sprinkle. You don't want to go too much high because, again, this is going to be scattered all over the donut. You don't want to go too high poly. So that'll do. So that's a simple bevel operation, and it's very common when you're modeling. So yeah, Control B is... how you do that. All right, so look at that. We've got one sprinkle. So now we will need to create 3 more. So this is the small. So let's go Shift D and then X to just move it along the X axis. This is going to be the medium one. So edit mode, and I'm going to go into toggle wireframe and vertice select mode. And now selecting the top part of the sprinkle, hit G. Z, and I'm going to move, oops, if you've got proportional editing, turn that off. G, Z, move that up. Okay, that'll be the medium one. Yep. And now Shift D, X, move it along. This is going to be the long one. So edit mode, and again, G, Z, move it up. And this is going to be the long sprinkle. I don't go too long, maybe that long. Okay. And then I want to make a bent sprinkle. It's slightly like, curved. So Shift D, X, move it across. And now with this one, if I was to try to like curve this out, there's not enough information here. Like if I move that, it's just a straight edge there. So if I want to make it curved, I got to have more geometry there. So like we've done in the past, Control R is how you create a loop cut. So when you do that, it says, where do you want to put it? I want more than one though. So I'm going to scroll up till I get, yeah, just a bunch of loops until I get what looks like square faces on those points, somewhere around that. I don't want to go too high poly. Yeah, like that. What is that? That's in the bottom left-hand corner. 8 cuts. Okay. Click, and then it's saying where do you want to place it. Right click to cancel the movement so it places it right in the center. And now, there we go. Okay. Now we've got this one over here that is just long and straight but low poly, and this one same shape but high poly. So to add a bend to it, in previous tutorials, I actually went into like edit mode and we did like proportional editing, and it was just complicated and it actually didn't look great. I've learned actually there's a modifier that'll do it very simply. Go to your modifier stack, add modifier. You could find it inside here, or you could search for it, but it's the simple deform modifier. So add that, and by default it is wrong, so change it from twist to bend. And look at that, we've got our sprinkle. And you can very easily, whoops, change the amount from a little curve to a large curve. And I think somewhere around the 30-degree mark. You will notice though that it's like it's bent more at this angle, and that's because it's bending it according to the origin point. So you see these little dots? You might have wondered what they are in Blender. That's called your origin point, and it's used for a lot of things. Like if you rotate an object, you can see it's rotating from the point of that origin point. Like physics, a bunch of things use the origin point. The best way to think of it is like the center of mass for the object. So generally speaking, as a rule of thumb, you want it to be in the center of the object. And you can do it very quickly. You select multiple objects you want to clear its origin point, shift, select all of them, and then right click and then say set origin to geometry. And now you can see it's put it in the middle, and now our curve is actually based on the starting in the middle, which is what we want. So yay for us. Now I need to apply this or else the next part will go wonky. So apply your simple deform so that it's actually realized onto the mesh. Okay, so going to your outline, you can see we started from humble beginnings, but we've now got too much going on, and it's all setting to get a little bit chaotic. So the way you organize things in your outline and in Blender generally is you can group things together by creating collections. So by default, we've actually got one collection already, just called collection, but we can create new collections by this little button in the top right-hand corner to create new collection. And I want to create it outside of our, I don't actually know if we need, I don't know why it creates a collection for you for no, you could just, it's in the scene collections. Anyways, I don't know if we actually need that one. So we create a new collection just by hitting that, and we can double click it to rename it to be whatever it is we want. So I'm going to call this sprinkles, okay? And because we have two types of sprinkles, we have the sphere round sprinkle and and then we have these long sprinkles. I'm going to create two other collections within this collection. So hitting new again, you can see it's placed it underneath it, and I'm going to call this one round. And then clicking sprinkles again, I'll add another collection, and this one I will call long. Oh, wait, sorry, this one, long. There we go. Okay, so to move something to a collection, you can do it one of two ways. One, you can select the sphere, which is the round. Remember, it's this little guy over here, the little tiny round sprinkle. You can just drag that into the that collection, and you can see it's now moved it there. The other way is in your 3D viewport. If you select all of the objects that you want to move to a new collection, hit M and it brings up this, and you just say move to the sprinkles long sub collection. There we go. And now they're all moved there. And now this one here, if you wanted to give this a name, you could. We got the camera, we got the light, we got the plane. Yeah, you know what? Let's move our donut and our icing. Let's move that to a new collection as well. So M, and we can actually create a new collection from the move options as well. So I'm going to go new, and let's call this let's say donuts, because we're going to duplicate it and make more donuts in the future. So donuts. Okay. Great, so now this one here has got the camera, the light, and the plane. So I'm going to do what I sometimes do with a scene is just call this one ENV, which is for environment. Since this is a tutorial, I'll actually just type it out. I'm not going to be lazy. Environment. Okay, so we've got some organization in our scene so that as we add and grow our scene, it's not going to get too crazy. All right, so it's also good that we've created collections because we can now use that to scatter across the geometry nodes. So with our donut here, so the icing and the donut, we're going to create a duplicate, and this is going to be the variant with the long sprinkles. So Shift D and then hit X to move it along the X axis. So it's just placed next to it, and then clicking your icing, you can see we've got the modifier stack that we created the geometry nodes on. And if we were to start tweaking this and make this look like long sprinkles, it would apply to this one over here, because we can see that little number next to it. And that number, if you hover over it, I think we mentioned it before, but displays the number of users sharing this data. So any change you make to this is going to be reflected on that one. So if we click the 2 button, it's now independent. So we'll now have 2 different versions. So the one on the left, the one that the original one, let's call that round sprinkles, and the one on the right, let's call that one long. Okay, brain fart for a second there. Long sprinkles. Okay, and now with that object selected, let's go back to the geometry nodes tab. Okay, all right, so make sure you're looking at the right object. Make sure it's the one with long sprinkles in the name. And if we were to start editing here, we would have we would have made one big mistake, and it's because this is actually not the long sprinkles node setup. We clicked the pin button. Remember that? The pin means it's always going to be there, even if it's another object with a different geometry node setup. So remember, yeah, it's a common mistake. You always do it. You forget you've got pin on and then you start changing things and it does the wrong one. So make sure you're looking at the one that has long sprinkles in the name. Okay, so the bit that obviously matters the most is this bit where it goes into our instance on points node, and we've currently got it connected to a sphere. So I mean, you could change that to another object, but that won't help us because we've got more than one object. We want to scatter 4 different objects across it. So we can delete that and instead just drag from your outliner. Don't just, if you click on it, if you click off it, it's just going to disappear. So make sure you don't do it. You've clicked the icing, but you need to click and drag into your node setup. And now it's got a collection info node rather than object info node. Drag that into your instance input, and nothing happened. It has actually happened, but it's off center in a weird place. Why is it doing that? It's because of the way 3D software handles data. It's now doing it on its like global or local position, not relative to, anyway, it doesn't matter. What you need to do is check 3 boxes whenever you use collections to scatter. Separate, reset children. Now it's on the mesh correctly, and then you can see it's actually using all 4 of them on each point. So then you click pick instance, and now it's going to use one of those, not all 4 of them together. Okay, so it's good. It's using it, but what's going on? Well, the reason this one was easier with its round sprinkles is that the rotation of the objects didn't matter because it was round. Now that we have long sprinkles, you can see the rotation matters, and it's currently screwed up. So how do we fix that? The first way, well, yeah, there's a number of things you need to do to make it work correctly. You'll see, is we want to take the rotation of the face. So the face of these mesh here, we want it to affect the objects, right? So we take the output of our distribute points on faces, the rotation of that, and drag it into the rotation input of the instances. And now you can see it's having some effect. It's still not right, but that is because these sprinkles are currently just pointed upwards. So it thinks, okay, well, you want to point them all outwards. Anyways, to fix that, I mean, you could fix it you could actually fix it in geometry nodes. This is simpler. So if we just rotate those sprinkles along the x-axis, so R, X, right? And then we just want to lie them down flat. So essentially 90 degrees. You could type in 90 degrees, or holding down Control will move it in 5-degree increments. Okay, so 90, and then do a single click. Okay, so why has that not worked? Well, it's because, as I mentioned before, when you're scaling or rotating things, it's not actually saved to the object. So to apply it, you have to go Control A and then say rotation. Now that we've done that, it's worked correctly. All right, so now you can see what I said by you need to do a lot to make it work correctly. The rotation is working, but it's not doing what you would expect, and that's because... All right, so now type in 90 degrees, or holding down Control will move it in 5-degree increments. Okay, so 90, and then do a single click. Okay, so why has that not worked? Well, it's because, as I mentioned before, when you're scaling or rotating things, it's not actually saved to the object. So to apply it, you have to go Control A and then say rotation. Now that we've done that, it's worked correctly. All right, so now you can see what I said by you need to do a lot to make it work correctly. The rotation is working, but it's not doing what you would expect, and that's because geometry nodes so flexible, you have to tell it exactly what you want to do. We want actually random rotation. So around each of the points, we don't want to each have the exact same rotation. We need to randomize it. So for that, if you want to tweak the rotation on anything between this point here, on this dotted blue line, let's just move that out of the way, we need to add Shift A, Utilities, Rotation, Rotate, not Euler, Euler. Yes, I know. They went with the weird pronunciation. I think it was a Frenchman, right? Could be German. Doesn't matter. Same, right? Just to annoy Well, the Europeans. Anyways, rotate Euler, and we're just going to drop it on that line till it lines up. Okay, so nothing's happened currently, but with this, we could change the rotation of our sprinkles up here. But you'll notice that as you rotate it, it's kind of weird. It's not the rotation that you would expect for each point. It's the relative to the Euler. Yes, I know. They went with the weird pronunciation. I think it was a Frenchman, right? Could be German. Doesn't matter. Same, right? Just to annoy all the Europeans. Anyways, rotate Euler, and we're just going to drop it on that line till it lines up. Okay, so nothing's happened currently, but with this, we could change the rotation of our sprinkles up here. But you'll notice that as you rotate it, it's kind of weird. It's not the rotation that you would expect for each point. It's the relative to the actual object as a whole, right? Which just means we need to change from object to local. And now, as you move it around, you can see we're able to rotate those sprinkles. But again, it's not changing like randomizing it. It's giving a solid value. So to randomize it, if we drag out of the rotate by input and then type in random, it'll bring up this, and we're looking for random value. Click, and now we get this. Ooh. So this node looks kind of scary, right? It's got a whole bunch of different values in it, and it says vector, and it's very, very foreign. It's actually easier to understand it from a float point of view. With the random value, if it's in a float state, it's going to generate a value from 0 to 1 on each point. So if you've got like 10 points, one of them is going to be like 0.015, one of them is going to be like 0.92, and one's, whatever. When it's in vector state, it's the exact same thing. You've got min and you've got max, but there are 3 values. And the reason for that is that there are 3 axes. There's the x-axis, there's the y-axis, and there's the z-axis. And same here, right? So you're able to define what type of rotation on each axis. So if we set both, and by the way, if you want to change multiple values at once in Blender, you can just click and drag down, and then you can change all of them. So we set all of them to 0. And now you could see this bottom one is going to be the Z, because it's X, Y, Z. It doesn't tell you, like, I don't know, because it's vector math, I guess there's other areas of Blender, anyway. But this is the Z axis. If we increase this one, you can see that's the main one that we want to change, right? Because that's the one that makes the most difference. Now you might also know, looking at this, you're probably thinking like, okay, well we need to rotate it by 360 degrees, so we would set this to 360. But you can see they're more than rotating fully already. So what value is this exactly? This is radians. Oh, just to get real. So radians, degrees. Actually, like, I had to ask ChatGPT before I recorded this. What's the difference? Radians are more mathematical and easier for mathematical equations. It's the circumference of 2 pi is the circumference. Look, obviously I don't know, but what I'm trying to tell you is it's you. GPT before I record this. What's the difference? Radians are more mathematical and easier for mathematical. Equations. It's the circumference of 2 pi is the circumference. Look, obviously I don't know, but what I'm trying to tell you is you just need double pi to make it 360 degrees, which is actually tau. To make it really complicated, it's tau. So double pi, so pi is 3.142, tau is double that, and anyways, you get the idea. So you can type in tau and it'll actually give you the correct value. So that's 360 degree rotation. We also want it, because you can see this is the other axis, like the middle one spinning around. So we also want it on that one, because we've got a curved one. So let's make that tau. And then this top one is the X, which is actually going to make it like wonky, like, so these will be like seesawing up. So if you increase that, that's where it gets crazy, and you don't really want to use that. You do want a little bit though, because it would make sense if they're sprinkles. They're not going to be completely flat. You're going to have some variance where like some bit has absorbed into the icing at a different angle than another, but just not too much essentially, or else it starts to look like little marshmallows or whatever all over it. But guys, that's roughly it. That's the hard work. That was, I mean, I know that was very technical, but it was just 2 nodes. Rotate Euler, set it to local, and then this random value, and we're changing that to rotate it. And we did it. We got nice looking rotation. Now, one thing we do have to change is the distance min. So because these longer sprinkles obviously are bigger, then the distance min has to change as well. So we can change that to something that makes sense. Let's go 0.04. That might have actually been pretty perfect. Let's try 3. 3's got a little bit. Oh, actually, you know what? The other thing, again, looking at reference, I like those big chunky looking sprinkles. So I want these to be bigger. So we could, alter the scale of the actual sprinkles, but we're working with geometry nodes and we've actually got a scale value right here. So we could change it here just as easily. So the scale, dragging down, and again, there's not just one value, there's 3 axes, so X, Y, Z, so drag down on all. 1.5 is gonna give us some nice, big, chunky looking sprinkles. And now this distance value needs to be a lot bigger. So let's go 0.06. That's actually pretty good. I'm getting pretty good at nailing it. 0.0, no, I was right before. There's always going to be some overlap, right? You're not going to be able to stop it because it's not doing object like collisions. It's nothing like that. It's a very simple, again, it's doing a point and then it's creating a radius around it. And if you do the correct amount, which for this is probably something like this, then it looks way too predictable and boring, which we don't want. So 0.0. 0.06 looks pretty good for me with a scale of 1.5 for these. And that is it. I was going to put in the random color in this part of the tutorial, but I think we've gone over already. So join me in the next part and we will finally add some color to our sprinkles and make this look nice. So join me in the next part. This is the part where we start making our donuts look sexy. So we're going to be coloring our sprinkles finally, so it doesn't look so depressing, and then also getting into rendering to start making this actually. Look pleasing with shadows and light and everything else. So first of all, the sprinkles. Now, as you probably know, you could come in here and you could select a sprinkle and then go, all right, I'm gonna make a red sprinkle, and then I'm gonna, don't do this by the way, I'm just showing you, make this aqua sprinkle and then a blue sprinkle, right? And this does work, does exactly what you would expect. The problem with this though is that for one, the color is locked to that. specific sprinkle. So this curved sprinkle is always red, okay? And the short sprinkle is always white. The other issue is that this is not easy to change the distribution of those colors. Like if I'm an artist and I'm looking at this, I'm like, that's kind of boring because all the colors is like 25% blue, 25% white, 25, you know. I want to have maybe 80% one dominant color and then a few splashes of complementary colors. I can't do that. So there is a much, much easier way. So first, let me just clear all of these, and I'm going to create one new material. I'm going to call it sprinkles, and I'll actually show you how to quickly apply the same material to multiple objects at the same time, because we haven't done that yet. So I'm going to grab my round sprinkle, which is currently still over there by itself. I'll just bring it over here so it's part of the family. There we go. All right, so I've got one object with the material that I want to and I'll actually show you how to quickly apply the same material to multiple objects at the same time, because we haven't done that yet. So I'm going to grab my round sprinkle, which is currently still over there by itself. I'll just bring it over here so it's part of the family. There we go. All right, so I've got one object with the material that I want to apply them all to. What I need to do is shift select all the objects that I want to have that material, and then lastly shift select again the object that has the material I want to apply them to, and you know that because it's highlighted yellow. Okay, then hit Control L. This brings up the link or transfer menu, and we want to link the materials. And now you can see our material has a 5 next to it because 5 objects are sharing this material. And that's it. And now obviously because they're linked, it means if I make a change over here, they're all going to be reflected. Great. Now we're going to do something fancy. So let's go to the shading tab, which gives us access to our nodes. Oh dear, where am I? All right, let's go back. I'm trying to get. Get to that sprinkle. Okay, to our nodes. Now I want to introduce you to a little friend called Shift A, input, the object info node. A very weird little node that just does introduce you to a little friend called Shift A, input, the object info node. A very weird little weird little node that just does some useful things when you might need it. So you see it pop up in a few tutorials. There's a bunch of stuff here that it can do. The most useful one for us in this instance is the random input. Drop that into your base color and let's see what happens. So we've got some gray values, and it's easier to see actually when you look at the donuts. So what this has done is it has assigned a value, a random value for each individual sprinkle between 0 and 1. So because that's then being transferred to color information, it means that, for example, this sprinkle might have got a value of like 0.023, right? And the robot spat that out. And then this one, this whitish looking one, maybe this was 0.89 or something like that. Okay, so it's just transferred those values into color information, which is just blacks to whites. Not very useful right now, but we can use that, those numbers in a, I'll just show you. Okay, Shift A, we're gonna go converter color ramp. Probably, I mean, I might have used this node more than any other node in Blender before. It's like so versatile, used for so many things. So drop it in here between the object info and the principled. And currently it is exactly the same because it's just it's transferring that data into a gradient value of the exact same. Not very useful right now, but we can use that, those numbers in a, I'll just show you. Okay, Shift A, we're gonna go converter color ramp. Probably, I mean, I might have used this node more than any other node in Blender before. It's like so versatile, used for so many things. So drop it in here between the object info and the principled. And currently it is exactly the same because it's just it's transferring that data into a gradient value of the exact same shades. But we can change this to any color that we want. And look at that. So you can very quickly see this is exactly how we're going to create sprinkles of different colors. Now, one thing you'll note looking at this is that every single sprinkle is a different shade. Like no two sprinkles have the same color right now because this is a gradient. And that's not how it works in the real world because the sprinkles come out of, you know, one constant icing bag, right? Or a machine with the same food dye. So basically all the blue ones would have the exact shade of blue and all the orange ones would have the exact shade of orange. So we need to change this from linear to constant. And now if I slide this across, look at that. We are influencing what percentage now is orange or blue. And this is really cool because it means you get to work like an artist and just create a really nice, appealing looking donut very, very quickly. So I'm gonna go with like a light blue over here. And then I'm gonna create a new color just by hitting the plus button. And then let's give this a purple like that. And I'll make this one pink actually, same shade as our donut, why not? You'll note by the way that I'm not going like full saturation, and that's deliberate because you learn in art that, yeah, like saturation and color is quite aggressive, it's quite noisy and quite attention grabbing. And so if you use too much of it, it can be exhausting. So I tend to keep it at like 0.8. Okay, and then I'll also go over here and I'm gonna make this white. Let's go, oh, whoop, no, not like that. White, and I'm gonna create another one next to it, and this one I'm gonna make yellow. Okay, so just by sliding this around, I could say like less white, more yellow, less yellow, more white, and then I can go, yeah, more blue. It's just a really simple, easy way to create the exact look you're going for. Awesome. Now, something, you don't have to do this next part, but it's so easy. Why not? I was looking on Pinterest on like aesthetically pleasing donuts, like trying to make this look really cool. And I saw like metallic sprinkles, and I was like, that's an interesting idea. What if I made these white and yellow ones metallic, and then they would look silver and gold? So there is a slider in your principled BSDF technical name that just means it's the shader that does everything. And it's the metallic shader. Look at that. So if I slide this all the way to 1, all my sprinkles are now metallic. If I slide it all the way to 0, then they are non-metallic. And that's actually how you should use this slider. All materials in the real world are either non-metallic, also known as dielectric materials, so that would be most of the sprinkles, and then some objects are metallic, entirely metallic. And there are technically a few rare materials on Earth that have some blend between it, but as a rule, you should not have a value that is between 0 and 1. It should be either 0 or 1. Anyways, so what we can do with this, because we've got this color ramp information here, is I can actually just convert, like I can make a color ramp that is just black and white that just shows which sprinkle is metallic and which one isn't. So if I duplicate this, and here's a pro tip, if you use Control-Shift-D, it will duplicate it, but it will retain its connection. So just saves you, I don't know, 1 second. And now I'm gonna connect that into my metallic input. Now currently this is wrong because this information is, it's just using, it's like color. So we need to be black and white. So this one here, because this is gonna represent my dielectric colors, I'm gonna set this to black, so it is non-metal. And then this I can delete, and this I can delete, because on the left-hand side of it, it's all black. Sorry, so it's all non-metals. And then over here, these two, the silver and the gold, they're going to be metal. So actually I can delete the gold, and now that's doing exactly what it should. So we've now got dielectric, non-metal. Metals and metals. And the reason it doesn't look like metal, by the way, is because your roughness is here. So if you set it all the way down, you can see it starts to look a lot closer to a metallic sprinkle. And by the way, you can get the exact like position. You can go like 0.7 and then here 0.7, type it in, and then that way it's definitely correct. For whatever reason of mine, this has to be a bug. There's something weird about it, but there's one sprinkle on my donuts, probably not on yours, but it's like, it's purple up here, but then it crept over into the metallic category down here, which shouldn't be possible, but evidently it's just on my donut. I've never seen it before, but one of them has actually snuck over. Doesn't matter. It's it can be the rare purple metallic one. All right, but I don't want these other ones to be shiny, at least that shiny. So I'm gonna again duplicate this, Control-Shift-D. And with this, if I plug this into my roughness input, just like before, these black and white values will decide what is the roughness of the metallic and non-metallics. So this one here, I want this to be essentially the opposite of what it is. Almost entirely black, a little bit, so there's a little bit of roughness to it, like that. And then this one over here, I want this to be a lot more diffuse. Not entirely diffuse, like somewhat of a blend, because if you look at reference, which you should be modeling off reference, there is some shininess to them. So yeah, but that is it. So you can see very quickly, we have created some very aesthetically pleasing donuts, and have fun with it, guys. diffuse. Not entirely diffuse, like somewhat of a blend, because if you look at reference, which you should be modeling off reference, there is some shininess to them. So yeah, but that. All right, but I don't want these other ones to be shiny, at least that shiny. So I'm gonna again duplicate this, Control-Shift-D. And with this, if I plug this into my roughness input, just like before, these black and white values will decide what is the roughness of the metallic and non-metallics. So this one here, I want this to be essentially the opposite of what it is. Almost entirely black, a little bit, so there's a little bit of roughness to it, like that. And then this one over here, I want this to be a lot more diffuse. Not entirely diffuse, like somewhat of a blend, because if you look at reference, which you should be modeling off reference, there is some shininess to them. So yeah, but that is it. So you can see very quickly, we have created some very aesthetically pleasing donuts, and have fun with it, guys. Like, create a cool looking donut. You can use whatever color combinations you want. I really do. Do like it when people experiment and not just follow a tutorial down to a T, but like venture out there and, you know, do interesting things. So try different color combinations, try different icing colors, and you could make something that looks really cool. But that's almost it for our donut. It's pretty well done, which means we can now finally talk about rendering. So as a recap of part one, if you hit F12, that's going to put you into the rendered state. Our camera is really far away from the donut. So actually, let's first fix that. If you go to your camera view, you can just by clicking that little icon there, or by hitting number pad 0, that'll take you there as well. This is the camera view. We're really far away. I mentioned in the start that if you use this key, this button, view, lock, camera to view, that'll let you like grab it and move it around. But there is actually another way. I didn't want to introduce you to too many keyboard shortcuts at the start, but if you hit with the camera selected, shift tilde key, that will put you in fly mode. The other way to do that, by the way, is to just go view, navigation, fly navigation there if you don't have that key. So anyway, in this mode, it's almost like you're playing a video game. So like it's just keyboard shortcuts at the start. But if you hit with the camera selected, shift tilde key, that will put you in fly mode. The other way to do that, by the way, is to just go view, navigation, fly navigation there if you don't have that key. So anyway, in this mode, it's almost like you're playing a video game. So like it's just, I'm playing a first person shooter looking around my scene. W is move forward, just like in a video game. A is strafe left, D is straight right, and S is back. So WASD, just like a video game. I can also go up by hitting E and then down by hitting Q. And if it's too sensitive, like if the movement is like, you know, crazy fast, the scroll wheel also decides how far, oh goodness, there it is, okay, how fast the movement is. So scroll down if it's going too quickly for you. But yeah, I can now place the camera wherever it is I want, and then when it's there, I just click, single left click, and that's there. And by the way, that mode is called fly navigation, and it works also not just from the camera view, but anywhere in Blender. If you ever want to just like, you know, move around, you can do use that fly mode. So shift tilde key for that. All right, so we do a render, we get something that looks hideous. Why is that? Well, for starters, it's not a very, the scene has just got one light in it. But the primary reason, and by the way, yes, that's the render view mode, but also if you go to rendered view shading up there, this is the exact replica of that, but just in the viewport, okay? Now, the primary reason this looks bad is because of the renderer, okay? So Blender's default render engine, if you go to your render properties, is called Eevee. Now, Eevee is fast, but it is not accurate. If you are familiar with games, most of review, but anywhere in Blender, if you ever want to just like, you know, move around, you can do use that fly mode. So shift tilde key for that. All right, so we do a render, we get something that looks hideous. How far, oh goodness, there it is, okay. How fast the movement is. So scroll down if it's going too quickly for you. But yeah, I can now place the camera wherever it is I want, and then when it's there, I just click, single left click, and that's there. And by the way, that mode is called fly navigation, and it works also not just from the camera view, but anywhere in Blender. If you ever want to just like, you know, move around, you can do use that fly mode. So shift tilde key for that. All right, so we do a render, we get something that looks hideous. Why is that? Well, for starters, it's not a very, the scene has just got one light in it. But the primary reason, and by the way, yes, that's the rendered view mode, but also if you go to rendered view shading up there, this is the exact replica of that, but just in the viewport, okay? Now, the primary reason this looks bad is because of the renderer, okay? So Blender's default render engine, if you go to your render properties, is called Eevee. Now, Eevee is fast, but it is not accurate. If you are familiar with games, most of you probably are, Eevee is basically a game engine. So it's designed to be really fast. Probably not 60 frames per second, but really, really fast. And it's in terms of the renderer types, there's usually actually, you call them like real time is what this type is. And that is a rasterized render engine. And then you have ray traced or path traced engines, sometimes called offline renderers, which are a lot more accurate but much slower. So this is good if you don't really care about realism. Like maybe you're making a title effect for a TV, you know, thing, whatever, or you're on a really tight deadline, you just want to get something out fast, you can use Eevee. Now you can make it look better than what we have. Like for example, I think because we're using like really small sizes for our donut, you want to increase your cube size and then your lamp, the bias. There you go. You set that all the way to 0. And now it's more appropriate for this size. donut, you want to increase your cube size, and then your lamp, the bias. There you go. What this type is, and that is a rasterized render engine, and which are a lot more accurate but much slower. So this effect for you can use EV. Now you can make it look better than what we have. Like for example, I think because we're using like really small sizes for our donut, you want to increase your cube size, and then your lamp, the bias. There you go. You set that all the way to 0, and now it's more perfect. Because we're using like really small sizes for our donut, you want to increase your cube size, and then your lamp. really small sizes for our donut. You want to increase your cube size, and then your lamp, the bias. There you go. You set that all the way to 0, and now it's more appropriate for this size. We've got shadows, but it's still not great. We don't, for example, have shadows on any of our sprinkles because it's just too fine a detail. And the shadow itself, it's just like a blurry mess. So it's just a fakery, and it's just like what's going on with video games. I will briefly mention also that Blender 4.1, which is what this is here, it's in alpha state at the time of this recording. I've been using 4.0 for this whole recording, but this is 4.1, and it's Eevee, but it's completely rewritten. And it is better, right? So the shadows are better. There is actually even some bounce lighting happening, but it's kind of like a fake bounce lighting. And it's definitely better, but it's still not great. So that is the limitation. It's fast, but it is not great. And that's what you get with rasterized real-time engines. So there is another render engine, to go to your render engine settings and click the drop down. Ignore Workbench, that's for just like basically rendering your viewport, really, for technical stuff. Cycles. So those are the two main engines of Blender. You got Cycles and you've got Eevee. Cycles is what's known as an offline renderer, or a path traced, also known as ray traced engine. Now, this looks way better than what we had before. You'll notice, for example, that all of our sprinkles have shadows. By the way, apologies if my recording gets a little choppy. It's because it's using the CPU to... Anyway, you can see it's got proper shadows on things. There's actually bounce lighting, right? That's like coming off this table here, and it's going underneath the donut. So it's like it's shooting around inside here, and it's shooting back, and it's going over here, which is exactly what happens in the real world. And it's really important for realism to get that bounce. I mean, any room, any architecture, you basically have to use cycles to do it, because that's how you get proper lighting like in the real world. But you get all this for free at the cost of speed. So you'll notice as I move around, whilst my recording goes choppy, that it starts grainy and then it kind of refines itself. And if you look in the top left-hand corner, you've got something that says samples. So as you leave it rendering longer, it's rendering more samples. Essentially, it's just like the computer's just chewing through it. There's technical ways to explain it, but that's the simplest way to think of it. And it'll get clearer as the longer you leave it. Now, there is actually two ways to calculate this. One is to use your CPU, which is what it's on by default. Another is to use your GPU, which is grayed out by default. So let's fix that. Go to Edit Preferences, and then go to System, and you can see at the top there, Cycles, Render Devices. So try switching to one of these tabs and see what you get. If you have a device, like myself, that is a GPU that is supported, then you can render on that and it'll be way faster. So just as an FYI, CUDA is NVIDIA, and it's for like cards, like I think 1080 backwards, so like 90s, 800s, I think they used CUDA. Optics was around the 2000 series further on. So Optics is the one that you use if you're using an NVIDIA card today. HIP is for AMD cards. And then you got one API. And I think actually on Apple devices, you'll have a metal option. But see what you have and then see if you can render with that, because that, with GPU on now, it'll, going back to this, it might actually, the first time you use your GPU, it will say, I think at the top left-hand corner, doing this for the first time, it'll do some pass, it'll be really slow. It might take like 2 minutes, but then after you've done that, every time you open Blender, you should never need to do it again. So it might be slow the first time you activate it, but it should be faster. Now, this is way faster than what we had before. Like you can see how quickly it's clearing through those samples. It's basically real time. In fact, actually, so that noise that I mentioned, right? It's still there, but when you render and also in your viewport, you can use a denoiser. So it's actually not that new. It's like 3-4 years old. I think we started using AI denoisers. NVIDIA released their one for optics, and since then Intel have come out with one. And it basically takes that noisy image, it uses some of the information from the 3D renderer to clear it out whilst preserving the detail. So if you can actually turn it on in the viewport by hitting the denoise one. If you've got an NVIDIA card, it'll be way better. If you don't, it'll have to use the Intel denoiser, which is a lot slower. but you can see the noise is practically gone, right? So this is almost real time, which is really, really cool. Now, obviously, not all of you are as lucky, right? I've got 4 3090s. I started though on a Pentium 3, I think back in 2003. And I mean, look, they made Toy Story on computers that you couldn't even sell today because they would be just garbage. Maybe you could for like nostalgic. Anyways, the point is that everybody, when they start 3D, is using a device which is crappy. Don't let it limit you, or don't think, oh, I can't use 3D until I get a better computer. A graphics card is definitely one of the best investments you can make if you're thinking like, I want to do this as a career. This is definitely for me. I'm really enjoying this. It's definitely a good investment because you will be able to produce more renders throughout the day faster, but it is not essential. You can get by with just a CPU. It just means that when you do your render, your final render, instead of it being, you know, done in an hour, you might have to leave it overnight. In the past, when I started with Blender, I was making crappy renders at like 600 by 400 resolution, and I was rendering for over a week just to do a really crappy basic animation. So don't let it hinder you. It's totally normal that you'll have a bad computer. If it's for you in the future, definitely worth investing in a card that is fast. Also, if you want to know which card to buy, Blender actually put together an open benchmark. So if you go to opendata.blender.org or click the link in the description, you can see it's showing you all of the people that have done this benchmark, what have their devices been, and what are the times that you can expect. So you can see, actually, mine is at the bottom. It's the 3090, but I've got 4 of them, so it's obviously churning through it faster. The fastest is, I mean, basically it's going to be the top card, or like the go-to. NVIDIA is just crushing it. I think, where is the AMD? They used to be on it. I think AMD's made a mention there. You've also got CPUs on this side, but essentially, I mean, just buy the top like gaming card. Usually that's the one. But do go here, check it out if you want. All right, so we're going to be using cycles for the rest of this tutorial, and we'll really dive into it in the next part, but I just want to quickly, my lamp is way, way away, so let's just bring that in closer just so that we can see things, and you can actually clear the rotation of an object to make it appear at the center of your 3D scene by tapping Alt-G. Okay, so now, hey, look, that's actually kind of cool. I'm going to move my lamp over to here. Just check my recordings. Yeah, my recording's not being affected. And I'll just now reduce the strength of this because it's obviously now way closer. But look at that, like look at the shadow that we get coming off this donut. It's like properly tapered. It's not like some fakery, so it's like tight here and then it's like really faded at the end there. That kind of stuff is really difficult to do with a rasterized real-time engine like Eevee. And you also get like all of this proper, like look at the shadows on the sprinkles, the reflections is actually true. It's not like guessing and fakery. Yes, it's a type of fakery, but it's much more accurate. Anyways, I like cycles. I'm a cycles guy. I think most people actually are. The first version of Eevee was not that great. Eevee Next in 4.1 might be better. We'll see. But yeah, the first version of Eevee was not really that great. Now, one thing you might notice looking at your donut, they're going to make one big tweak to this is that it kind of feels hard. Like the donut doesn't give this kind of like soft feels for the rest of this tutorial. And we'll really dive into it in the next part, but I just want to quickly, my lamp is way away. So let's just bring that in closer just so that we can see things. And you can actually clear the rotation of an object to make it appear at the center of your 3D scene by tapping Alt-G. Okay, so now, hey, look, that's actually kind of cool. I'm gonna move my lamp over to here. Just check my recordings. Yeah, my recording's not being affected. And I'll just now reduce the strength of this because it's obviously now way closer. But look at that, like look at the shadow that we get coming off this donut. It's like properly tapered. It's not like some fakery, so it's like tight here and then it's like really faded at the end there. That kind of stuff is really difficult to do with a rasterized real-time engine like Eevee. And you also get like all of this proper, like look at the shadows on the sprinkles, the reflections is actually true. It's not like guessing and fakery. Yes, it's a type of fakery, but it's much more accurate. Anyways, I like cycles. I'm a cycles guy. I think most people actually are. The first version of Eevee was not that great. Eevee Next in 4.1 might be better. We'll see. But yeah, the first version of Eevee was not really that great. Now, one thing you might notice looking at your donut, they're going to make one big tweak to this, is that it kind of feels hard. Like the donut doesn't give this kind of like soft feeling to it. And the reason for that is the material. So by default, all materials are, yeah, kind of like hard materials, but fleshy objects like humans as well as food have subsurface scattering. So I'll throw some reference photos here. But you can see this is my hand. I had light coming in like as I was eating breakfast, and I can see the light is actually going through my fingers, right? So that's light that is like, yeah, it's a mushy, fleshy object. So it's passing through it, scattering amongst all the other atoms in the finger, and it's the light is going through to the other side. You also see it in a lot of food. So took these photos at a party. Yes, I am that guy. But you can see that's how you get light that goes to the opposite sides. My daughter was eating a banana, and I was like, look at that banana. Look at that subsurface scattering right there. So donuts and icing have that. And we can do that. We can add that, sorry, by going to the materials. And then down here, you've got subsurface. Okay. So here, the biggest one to turn it on. And just like metallic, apparently, this is, by the way, a new setup for 4.0, but just like metallic, it's supposed to be a weight of either 0 or 1. All right. Now, when you do 1, it suddenly turned blue, and you're like, what the hell happened there? That's because the radius, this radius, is this is your X, Y, Z, but also it's your R, G. And your B in this case, and these values are different because it's designed for skin by default. So this is a great setup if you've got skin with blood inside, but we don't. So click, drag down, and then just set these values to 1. All right. So now it's closer to the material, still looks weird, and that's because the scale of this is wrong. It's saying that the thickness of the object is 5 centimeters, but this icing is not that. So let's make this 0.01, and now you can see it looks a lot closer. It's still a little dark, because I think it's not 1 centimeter thick, so let's go 0.005. And now we can see it's pretty close to. To its original material. The biggest difference is if I just zoom right in here, let's set it to what it was before. See how it's hard? It almost feels like, it just feels like concrete, right? But then you set this to 1, and look at that. The shadow just starts to feel a little softer, and you get this bleed effect where kind of like the shadow gets like an edge to the shadow where it gets a little more saturated and pinker, and that's subsurface scattering. You don't have to tell it how to do that, it just does it. So you set the weight to 1, these to 1, and then you just set your scale to whatever it is you want. And I'm also going to do it for my sprinkles. So I'm just going to click on one of my sprinkles, and yeah, right in here for the subsurface, I'll just do the same thing, set the weight as 1, these radiuses to 1, and then I'll use a really low value here, like let's go 0.0. Two, and now you can see, because these sprinkles are, yeah, it's like icing, right? It's just the exact same thing. Yeah, we want some of the light to pass through it, and we don't actually have to bother setting up that that color ramp system for the metal, because metals automatically, that shader, when you set it to 1, it means it's going to cancel any subsurface scattering that would have appeared there. So we don't have to bother with it. The subsurface is not going to happen on metals. But you can see it starts to feel a lot softer, a lot, I don't know, more pleasing, more delicious looking, like real food, because that's really one of the telltale signs of food is subsurface scattering. Awesome. So in the next part, we're going to start really... really building out the scene. What I want to do though at the end of this video, I want to give you some homework, and that is to try to model this plate. Now we're going to do it actually in the next part, but it's simple enough and it's actually possible to use all the tools that I've mentioned in this this series so far to model this yourself. Now the reason I'm trying to give this as homework is that once this tutorial finishes, that's how it's going to be. You're going to have to try to solve problems on the fly. So it definitely helps solidify learning if you can try to apply it by yourself. So have a go. It doesn't matter if you get stuck or you fail at it terribly, because you can just click the next part and see how it's done. But have a go at it now, because then you'll start to, you'll just retain the information a lot better. Anyways, go ahead, click here and see how we build the rest of the scene.